Welcome to the channel. And our today's subject of discussion is another very important speedometer test applicable to automobiles, motorcycles, and scooters. And the test is Vibrations Endurance Test. Vibration endurance test related to automobiles, motorcycles, and scootometer is a key mechanical reliability test that simulates long-term exposure to vibration to evaluate how the speedometer and its components perform over time under realistic or exaggerated riding conditions. A vibration endurance test subjects to entire speedometer assembly to continuous or cyclic vibrations of for an extended period to assess four things. Number one, structural integrity. Number two, functional reliability. Number three, resistance to mechanical fatigue. And number four, related to digital speedometer, and that is electronic stability. Well, this is not just a quick sweep through vibration frequency like in a resonance test. It is a durability test under prolonged vibration conditions. The purpose of the test is to simulate the lifespan of speedometer under real world riding conditions, especially on rough roads, and to ensure that it can withstand the vibrational stresses coming from three important sources, and that is number one, engine operation, especially single cylinder or high revving engines. Number two, road impacts, that is potholes and off-road riding conditions. Number three, chassis and handlebar resonances. The typical setup for this vibration resistance test is to start up with is mounting configuration. The speedometer is mounted on a vibration test bench, electrodynamic shaker or hydraulic shaker, in the same way as it would be mounted on a motorcycle or scooter. The vibration is applied in one or more directions, that is X, Y, Z axis. Random or sinusoidal vibrations may be used depending upon the specifications. The test can range from several hours to hundreds of hours depending on the required endurance level. For example, 10 hours, 72 hours, or more. The term sinusoidal vibrations. These are the vibrations that move back and forth in a smooth repeating wave pattern, just like a sine wave. In a vibration endurance test for speedometers, the test machine shakes the speedometer up and down or side to side in a continuous, regular wave motion. The frequency and amplitude are controlled and gradually increased. This helps checks whether the speedometer can survive long-term, realistic road vibrations without damage or malfunctions. The typical test sets includes frequency ranges from 10 Hz to 2000 Hz, typical test conditions, accelerations from 3 to 5G vary. It can vary depending upon the test specification or testing conditions, and test may include thermal cycling too, that is heat and cycle, that is heat and cold, during vibration test or combined stress testing, and it would be a very severe test. What are we going to evaluate under vibration resistance test? That is, during and after the test, the speedometer is inspected for number one, needle movement. There should not be any sticking, no fluttering or jumping. Number two, display function. If it is digital, no flickering, no data loss or dead pixels. Casing integrity. There is no crack, no loose joints or warping. Mounting points, no loosening, no bending, and no cracking. And internal connections, no solder breakage, no wire disconnection. And finally, the most important thing, that is accuracy retention. Speed indications remain within calibration. Applicable standards would be ISO 16750-3 2012 road vehicles testing for electrical and electronic equipment for mechanical loads. SAE J1211 recommended environmental practices for electronic equipment design. IEC 60068-2-64 environmental testing random vibration including broadband testing, and IS 14626, this is Indian standards related to automotive electrical equipment vibration test standards. Let's come to the real world example. A manufacturer might test a speedometer designed for an off-road conditions for off-road motorcycles. The test duration could be from 24 hours of vibrations at 5G across three axes. And the post-test check includes needle must function smoothly, no display glitches, and the mounting must be intact. If it fails, the design may be reinforced. For example, taking action regarding better PCB supports, damping materials, or revised needle pivot. A vibration endurance test evaluates how a motorcycle withstand prolonged exposure or a motorcycle speedometers withstand prolonged exposure to vibrations, simulating real-world conditions. This test is crucial for ensuring the durability and reliability of the speedometer over time. Vibration endurance tests are set up for speedometer, motorcycles, and scooter speedometers. Number one, shaker table, that is vibration exciter. It is a device that generates controlled vibrations. The speedometer is mounted securely on the shaker table. Then accelerometers, sensors are attached to the speedometer to measure the vibration it experiences. Then comes controller and amplifier. The controller defines the vibration profile, that is, frequency and amplitude. The amplifier powers the shaker to produce the desired vibrations. Then comes data acquisition systems. It collects data from accelerometers to monitor the vibrations and speedometer response. Test procedure includes number one to start with mounting. The speedometer is securely fixed to the shaker table to prevent movement during testing. A predefined vibration profile is applied, typically involving random or sinusoidal vibration across multiple axes. The speedometer is subjected to vibrations for an extended period, often several hours, to simulate long-term use. We keep on monitoring through accelerometers and the data acquisition system, which continuously monitor the vibrations and the speedometer's performance. And finally, after the test, the speedometer is inspected for any signs of damage, such as loose components, cracks, or malfunctioning parts. The importance of vibration endurance test is number one, durability assessment. This test ensures the speedometer can withstand the vibration encountered during normal motorcycle operations. Then it is important to identify weak points. It helps identify components that may fail under prolonged vibrations, allowing for design improvement. Number third importance is to ensure compliance with the standards. That is, it meets industry standards and applicable regulations for automotive components. And finally, quality assurance. It provides confidence that the speedometer will perform reliable over its expected lifespan. Here is the diagram of a shaker table design for electronic device vibration test systems, consisting of electronic device, a digital shaker table, and the shaker. The term which we have used in this test, that is acceleration G force, and in certain cases stating 3 to 5G, the acceleration G force 3 to 5G meaning in vibration testing. G force, that is, G stands for gravitational acceleration, and everybody knows that 1G is equal to acceleration due to gravity at Earth's surface, that is 9.81 meters per second squares. Therefore, 3G means an acceleration force that is 3 times the force of gravity, that is 29.43 meters per second squares. In the context of vibration testing, when a vibration endurance testing specifies 3 to 5G, it means that the speedometer is subjected to vibrations that cause it to accelerate back and forth with a force 3 to 5 times the Earth's gravity. This does not mean the part is being dropped or thrown. It refers to vibration motion where the component is rapidly moving back and forth due to the shaker table's movement. Why use high G forces? The motorcycle components like speedometers experiences intense vibrations coming from high revving engines, road irregularities, off-road or sporty usage. By applying 3 to 4G in control test simulates or exaggerates real world stress, helping ensure the speedometer does not shake, maintains accurate readings, and does not suffer from fatigue over time. It is like, imagine holding a speedometer in your hand while someone shakes your arms violently 50 times per second with a force of 5 times that of a gravity. That is similar to what the shaker does in the test with 5G accelerations. A small technical note about this test. In vibration test, G-force is usually controlled through amplitude, that is how far it moves back and forth. Frequency, that is how fast it vibrates. They are adjusted to create the required acceleration using this test formula simplified for sine waves, where where F is frequency in hertz, A is displacement amplitude in meters. The formula is acceleration g is 2 pi f square multiplied by A divided by 9.81. With this, we conclude our discussion on the subject of speedometer vibration test. Stay tuned and please do not forget to hit like, share and subscribe button to receive the similar contents in future too. Thank you and thank you very much.